Hello my dear students, this is Akash HD and welcome to the HD Physics classes. Hope so you all are doing really great. So students, in this video we are going to learn the combination of capacitors, and you know two types of combinations are there. One is series combination, parallel combination, and by mixing both of them we can make mixed combination also. Okay students, so let's start the video and let's learn one by one. Okay, so students, here you can see the first one is the series combination. Okay, series combination. So see here, what is this? See, in series combination, charge on each capacitor remains same, very important, and equal to the charge supplied by battery. Okay, but potential gets distributed as shown in circuit diagram. That means what we are understanding, charge will be same on each and every capacitor, but potential will distribute. Okay, so now we are going to see this, how to draw the circuit diagram. So students, can you see here please? No, this is the one capacitor, is it? Similarly, this is the second capacitor, and after that this is the third capacitor. Okay, and let's take here I have taken the here point A, and let's take here point B is there. Okay, and students, let's see here the capacitance is C1, this capacitance C2, this capacitance C3. Okay, and students, let's take here, this is connected to a battery. No? One battery is there and it is connected to a battery. How much here? Potential V, is it? And you know very well what I am telling, the charge on each of them will remain same. That means students, if I write here, let's take here, if this is plus Q, here minus Q. If here plus Q, here minus Q. If here plus Q, here also minus Q. So what we are going to find out? We are going to find out the equivalent capacitance. That means students, a single capacitor which can replace these capacitors. Okay, so students, here please, here I have written this, let's take CS. Okay, and anyhow the charge on this will be how much here? Plus Q minus Q, is it? And let me give here the terminals A and B. No, see here very well. Now after that we will connect to the battery here, is it? So what we are going to find out? We are going to find out the value of CS in terms of C1, C2 and C3. Okay, so this diagram is ready now. Now students, after that, here potential V is there now. So see, across the capacitor, here potential is how much here? V1. Let's take here potential is how much here? V2. And similarly here, let's take students, here potential how much here? V3. If the capacitors are different, then potentials will be different. Now that we'll see in a detail later. So you can see very well, potential gets distributed as shown in circuit diagram. So students, here what will happen, that here as potential will get distributed. So here V equal to V1 plus V2 plus V3, is it? Now students, you know very well, as the charge on the capacitor is same, and you know very well Q equal to CV. So what is V? V means here students, we can write here, see here. Now here potential difference, how much students here? See here potential difference is how much? V. So we can write here V means Q by CS is equal to V1 how much here? Q by C1. Okay. Next one, similarly students, see Q by C2 for second capacitor, and how much here? Plus Q by C3, is it? So you can see very well, both the sides Q and Q will cancel out. That means what we'll get here? We'll get here 1 by CS equal to 1 by C1 plus 1 by C2 plus 1 by C3, is it? So students, here this formula we will get it when the capacitors are connected in series. Okay, after that now we will see some important points related to this one, but remember that your charge will be same on each and every capacitor. Okay, next one here students, see. Okay, so here what is happening at, see students, important points in series combination. First one, see, if n identical plates are arranged in series combination, then they constitute n-1 capacitors as shown in circuit diagram. Which kind of plates are there? Identical plates are there. Okay, so let me write here the plates here. See, this is a terminal here. Let's take, I have taken the first plate, no? And let's take here students here, see, second plate. Let's take here third plate is there. Okay, like this plates are there now. And students, let's take here, this is connected to one battery. No? Connected to one battery. So you can see here the plates are 3, is it? 3 or 4? See here, count 1, 2, 3, 4. 4 plates are there. Okay, but here how many capacitors will form? Here the capacitors will form 3. How? You see here, please see. I'll give a name here, 1, 2, 2, because this plate will constitute 2 capacitors, one left side, one right side. 3, 3, and here 4. Now, so one capacitor 1, 2, and 1, 1, 2, 3, and there 1, 3, 4. Okay. So students, if I write here the diagram here, the equivalent diagram here, see this. How many capacitors will form here? This capacitors will form here. Okay. This will be C12. This will be how much here? C23. This will be how much students here? C34. Okay. And here this one is there. Now what will happen that here? These all capacitors will be identical. Is it? So whether C12, whether C23, whether C34. Okay. All this value will be how much here? Epsilon naught A by D. Now, or identical capacitors. So students, again I am telling you, see, we know here 1 by Cs equal to 1 by C1 plus 1 by C2 plus 1 by C3, is it? So here what we can write here, see, 1 by C plus identical now, 1 by C plus 1 by C. Okay, this all is there now. Let's take here, I have taken all of them is C, now, all identical, is it? So what will happen that here, students, see, this will become here 1 by Cs is equal to, how much will become here? 3 by C. Hence, Cs will become what? Cs will become here C by 3. So when 3 capacitors is connected in series identical, what is the formula? C by 3. 4 means C by 4. 5 means C by 5. Similarly, is it? So see here please. So see here it will become here what? 1 by 3 epsilon naught A by D. Is it? This one we have got it. Now from here we have to make one main formula. So here how many plates are there? N plates. So how many plates here? 1, 2, 3, 4. 4 plates are making how many capacitors? 3 capacitors. Similarly, N plates will make how many capacitors? N minus 1 capacitor. Okay. So I can write here in this Cs equal to here epsilon naught A by N minus 1 into D. Okay. N plates means how many capacitors? N minus 1 capacitor. Okay. This formula, kindly remember that. This is the formula here. Okay. See here very well. When N capacitors are means N plates are connected in a like this manner. So how many capacitors will form? N minus 1 capacitors will form. Okay, great. Now let's move to the next one. See, in series combination, plate separation of plates gets divided by dielectrics, but area remains same as shown in circuit diagram here. Okay, so here actually what we are talking about, the dielectric series combination. So see here please. See, here I have taken this one. Plates are there. Let's take here terminal A and here terminal B. Okay. Now what I am going to do here? Okay, terminal A and B will not take here. Why? Because plate area I am going to take here. What to tell? Plate area I am going to take here A. Okay. So let's take, I have taken here the terminal. Okay. Anything? Let's take, I have taken here M and N. Which terminals are there? See here. M and N terminals are there. Okay, and here I have put the dielectric. See here the dielectric is there. Is it? This side dielectric. Okay, and this side also I put the dielectric. See like this. So here what statement is telling that only the distance between the plates will be divided here. See, let's take here this is D1 and this is how much? This is D2. But this dielectric how much area? A. This dielectric how much area? A. Okay, and this both of them connected in a series. Okay, students. So see here. If I draw here the equivalent diagram, it will go like this. Here, see, 2 capacitors will be there. Now, and anyhow, here terminal M, here terminal N. Is it? And which colors I have put here? See here, yellow. Now, and another what is there? This is the green. Is it? So 2 capacitors. Let's take here C1 and C2. Okay. So we can write here C1. C1 how much here? Dielectric constant also we should put here. Let's take here dielectric constant K1, here dielectric constant K2 here. Okay. So this will be what you see? K1 epsilon naught A by D1. Is it? For this capacitor, C1 here. Okay. Similarly, see here, next one, C2. C2 will be what? K2 epsilon naught A by D2. Okay. So now we can use here the next one. See, as they are connected in a series, so 1 by Cs equal to 1 by C1 plus 1 by C2. So just you have to put the value. C1 value will come what here? See, K1 epsilon naught A D1. Just reverse. And here how much will become here? See, K2 epsilon naught A by D2. Is it? Then after that you have to just simplify this and you can solve any question related to this, no? Based upon the dielectric. Okay, great. Now we are going to see the very important point, third one. See, again in series combination, potential difference and energy distributes in the inverse ratio of capacitance. Why? See here, we'll see one by one. First we are going to see about the potential difference. Okay, so you know very well, as I have told you, V1 means what we have seen. Just think about the diagram. V1 equal to Q by C1. V2 was how much? Because charge is constant. Q by C2, and V3 was how much? V3 was Q by C3. Okay. So this one was there, and after that, hence, if I write here, see, V1 is to V2 is to V3. What will become here? See, 1 by C1 is to 1 by C2 is to 1 by C3. So inverse ratio. Okay, see here, inverse ratio is there. Okay, and we know one more thing. What we know? We know V1 plus V2 plus V3 is equal to how much? V. Okay, so if I make here, this is equation 1, and I make here, this is equation 2. So even we can write individual voltages also. You know what will be the individual voltage here? See, if I write here the V1 will be, see, 1 by C1 by 1 by C1 plus 1 by C2 plus 1 by C3 into V. Okay, similarly, yes please, what will be the V2? V2 will be, let me change here the just color. Okay, so 1 by C2 by 1 by C1 plus 1 by C2 plus 1 by C3. Individual voltage we are writing here. Similarly, students, if I write here V3 will be what here? If I write here the V3 here, so see, V3 will be, see, 1 by C3 by 1 by C1 plus 1 by C2 plus 1 by C3 into V here. Okay, so in this way we can get here the voltages. Now after that, if we talk about here the energy also, what is their inverse ratio? You know very well what is constant. What is constant? Charge is constant. Okay, so if I talk about here the second one here, when the charge is constant, we will use this formula, U equal to Q square by 2C. So if the charge is constant, we can write here this U. Now this U is inversely proportional to C. Now this U is what? Inversely proportional to C. Okay, so if in case I have to divide here the energy, okay, energy, so what we can write here? See, U1, U2, U3. What this will become here? See, 1 by C1 is to 1 by C2 is to 1 by C3. Okay, so up to this much basics you should remember that. Here we have seen the potential also, and we have seen the energy also. Okay, great. Now students, next one you can see here. See, fourth one. If n capacitors of equal capacity are connected in series with supply voltage V, then the equivalent capacitance and potential difference across each capacitor is given by. Okay, so first one, what we are going to see, equivalent capacitance. Which capacitors is there? N capacitors of equal capacity. Okay, so see here, if I talk about here the capacitors, N capacitors are there. Now so see 1 by Cs equal to 1 by C plus 1 by C plus 1 by C. Now N capacitors, not N plates. Okay, so how many times? N times. So you know what will happen here? See here, this will become here 1 by Cs equal to N by C. Okay, so hence Cs how much here? Cs is given by C by N. What is this? Cs is given by C by N. Okay, 3 capacitors means C by 3, 4 capacitors means C by 4, like this. Okay, now after that, if I talk about here the next one, what they're telling here, the potential difference across each plates. So what will become here? See, you know very well, see, V1 plus V2 plus V3, how much we know? V. So if in case the potential is same, so what we can write here? See, if all the potentials are same, because if capacitors are identical, potentials are also identical. So what we can write here? V1 plus V1 plus V1, how much? V. So can you tell very well? V1 how much here? V by 3 for 3 capacitors. Which capacitors? 3 capacitors. But if in case N capacitors are there, N capacitors, then potential difference will be what here? See here, for N capacitors, I can write here, see, whether V1, V2, V3, dot, Vn. All of them will be how much here? This will be V by N. Okay, so you can see very well, the capacitance will become C by N, and the potential will become what? Potential will become V by N. Okay, great. Now we are going to move for the next one. And what is this? Parallel combination. Now you see, in parallel combination, potential difference across each capacitor remains same. Remember that. Okay, and after that, see, and this is equal to the applied potential difference. Now, but charge gets distributed. What will distribute? Charge will distribute here according to the circuit diagram. Okay, so what I will do here, I am just going to draw here the circuit diagram. Now the capacitors are in parallel. Okay, so see here I have taken one capacitor now, and after that let's take here also I have taken one capacitor, and see here also I have taken one capacitor, like this. Now All of them connected in a water parallel. Okay, and this one is connected to the battery like this. Now battery is there, battery, now like this, battery is there. Now what will happen that here, let's take the capacitance values are C1, C2, C3, is it? Now what will happen that as the capacitance values are different, the charge will be what? Different. Okay, so let's take here how much charge? Plus Q1 minus Q1. Second one, how much charge? Let's take here on this plate, plus Q2 minus Q2. Okay, and next one, let's take how much charge? Let me take some different color. So plus Q3 minus Q3. Okay, charge will be different. Why? Because the capacitor values are different. Okay, even if you wish, it is getting somewhat complex. Not so many things are there. You can put in a circuit also, no problem. Okay, so what will happen that here the charge will distribute here. Now, so what we can tell here, I'll draw here the one equivalent diagram. Equivalent diagram is something like this. Okay, see here. This is which diagram? This is the equivalent diagram. Now, V is here. No, battery. Now, what will happen that here? Let's take here. Charge is how much? Charge is this one here. Plus Q and here minus Q. And how much potential is there? Potential is V anyhow. Okay. So, what will happen that students here? We can tell here. Q equal to Q1 plus Q2 plus Q3. Okay. Now, if we see here, this equivalent diagram here, Q how much here? C into V. C into V. And equivalent capacitance. Which one? Equivalent capacitance. Let's take here, this is CP. Parallel combination, is it? So, we can write here CP into V is equal to C1V plus C2V plus C3V, because each and every capacitor connected in parallel, what is same? Potential difference is same, and that is equal to which potential? Battery potential, is it? That means what will happen right here? This VVV all will cancel out. So, we can write here CP equal to C1 plus C2 plus C3. Okay. So, you can see very well in parallel combination how we have got this one here. Okay. And this combination is somewhat reverse from the resistance. Now, resistance you know very well. So, series will become parallel, parallel will become series here. Now, if you are comparing resistance and capacitance. Now some important points is there. See, what are the important points are there? One by one, we are going to see now. See, if n identical plates, again I am telling plates, not capacitor, are arranged in parallel combination, then they constitute n minus 1 capacitors as shown in circuit diagram. Okay. So, here what we can do here, see, now we are going to connect like this. See, this is one plate, this is one plate, this is one plate, this is one plate. So, parallel combination means, remember that what will happen that here students, alternate plates will be connected to the battery. So, here 1, 2, 3, 4. So, which plates are alternate? If I talk about here 1 and 3 is alternate. Okay. So, this will be connected to the, let's take terminal A, and here let's take here this one. This one will be connected to water B here. Okay. And after that we'll give the numbers, some numbers here. Okay. 1, 2, 3, 4 already is there now. So, see, this one is only this single plate, but this one is going to make 2 capacitors. This 3 is going to make 2 capacitors, and this 3, 4. So, how many capacitors are there? Plates are 4. First we will learn for the 4, then we'll make it for the n also. Okay. So, how many capacitors? 4 plates, but how many capacitors? 3. 1, 2, 3. If I will give the name also, see, this one will become here C12, this will become here C23, this will become here what? C34. Okay. So, what will happen here, students? We have to just draw here the equivalent diagram is there. See, this is the A. Okay. So, you can see very well from A, how many capacitors are going? See here, please. This is 1, then after that 3, then after that 3 here. Okay. And let's take here. These are the plates are there. Now, you can see very well. Now, A is connected to 1, 3, 3. After that, what will happen here? Next one, see, this B is connected to 2, and after that 2, 2 and 4. Okay. So, see here please, this 2, this is 2, and after that what is there? 4. You can see the C12, C23, and what is this? C4. And here it will be connected here, and this will be connected to terminal B. Now, you can see very well all of them are connected in what? All of them is connected in a parallel. Okay. So, what we can write here, see, this whether I write C12, before also I told C23, or I write here C34, no? 1, 2, 2, 3, 3, 4. Okay. All this value will be C, and how much here? Epsilon naught A by D. Okay. And next one, if I write here the parallel combination, so CP equal to C12 plus C23 plus C34. All are identical, C plus C plus C, that means how much here? 3C. So, hence students, we can write here this CP is given by 3 epsilon naught A by D. You are getting how many plates are there? Plates are, just think here, plates are how many? Here plates are 4. You count 1, 2, 3, 4. But what we are getting? 3. That means we are getting the capacitance. What is this? Here 4, but here we got 3. So if I write here for n plates, how many plates here? See, for n plates. No? For n plates. N plates, what formula will come here? See, it is given by Cp equal to n minus 1, okay, epsilon naught A by D. Is it? So see here, very well, we have done for the parallel combination of the plates. Okay, great. Now students, let's see for this one here. No? Second point, see, in parallel combination, plate area gets divided by dielectrics, but distance between them remains same here as shown in circuit diagram. Okay, so again I'll make here, see, again I will make here the plates here like this. Okay, and see, identical plates here M, and here how much here? N. Okay, terminals are there. Now what will happen that here distance will be same but area will get divided. Let's take here, this is one capacitor, this one dielectric is there. Okay, and let's take here dielectric constant is K1, and this one is covering how much area? This one is covering area A1. Okay, and distance how much here anyhow? This distance will be D. Okay, similarly if we go for the second one, see, this is the second one here. Is it? Let's take dielectric constant is K2. Again, distance how much here? D. But this area, let's take this area is how much here? A2. Is it? So students, what will happen that here? If I write here the individual values here, no? Let's take, for example, let me draw here the equivalent here. Okay. So what will happen that here? The students will be equivalent will be like this here. No, like this. This is the equivalent is there. Okay. This is N, and what is this? This is M. This I have taken C1. This I have taken C2. Okay. So can you tell me what is the C1? C1 is given by K1 epsilon naught A1 by D. No, you can see from here. You see, area is different. Similarly, students, C2 is given by C K2 epsilon naught A2 by D. Okay, so hence in parallel combination, what will become? Directly we can write here C1 plus C2. Put the values. What are the things are constant? Epsilon naught by D is constant. Okay, constant. So what this will become here? It will become here K1 A1 plus K2 A2. Is it? So this is in case of dielectric, how to identify this parallel combination. Okay, great. Now students, let's see. Next. See, in parallel combination, potential difference and energy distributes in the direct ratio of capacitance here. Which one? Direct ratio. So first one we are going to see one by one here. What is the first one? Potential difference. So you know very well, Q equal to CV, is it? But potential is constant. So here please, I can write a C. Q1 is the C1V, is it? Q2 is the C2V, is it? And Q3 is the, what is this? C3V, because potential difference is same. Okay. And we know one more thing, you know very well, Q1 plus Q2 plus Q3, how much? Q. Okay. And if we take the ratio of this, so we can write here, see, Q1 is to Q2 is to Q3, how much? C1 is to C2 is to C3. Okay. So this thing we have to remember that. Based upon that, if I write here the individual values, so see, this Q1 will come here C1 by C1 plus C2 plus C3 into Q. Okay. I have made it. Let's take this is the equation 1 and this is equation 2 by using these two equations only. Okay. Similarly, if I write here the Q2, no, let me change here the color. So Q2 will become what here? See, C2 by C1 plus C2 plus C3 into Q. Is it? Next one, if I write here the Q3, see, Q3 here. Q3, what Q3 will become here? See, C3 by C1 plus C2 plus C3 into Q. Is it? So this one we have done for the charge. Charge, see, Q1, Q2, Q3 we have got here, no? And after that here, what we tell? See, in the question what they told, potential difference also. Potential difference, okay, that is okay. Students, if I talk for the energy, what is there? Let's take, if I talk for the energy, see, second one, energy. So you know very well for this combination what will happen? We have to use the formula U equal to half CV square. Okay. So here what will happen, that students here, see, here as the voltage is same, no? So U directly proportional to C, and hence you can write here U1 is to U2 is to U3. How much will come here? C1 is to C2 is to C3. And here I will do one thing here. In a series combination, the potential divided, but in a parallel combination, what is will become here? It will come here charge. Not that we have done here. Charge will be there. Kindly see here very well. Both the things we have Done it. Okay, great. Now students, see next point here, see 4. If n capacitors of equal capacity are connected in parallel with supply voltage V, then their equivalent capacitance and charge on each capacitor is given by. Okay, so here which kind of capacitors are there? Identical capacitors. First one, what they are talking about here, the equivalent capacitance. See, very easy, we know very well. See, Cp equal to C1 plus C2 plus C3. Now, so if the identical capacitors are there, so C plus C plus C, what is coming here? Cp equal to 3C. I am telling n capacitors, not n plates. Okay, so hence for n plates, for n capacitors, okay, for n capacitors, what we can write here? Cp is equal to Nc. Cp, how much here, students here? Cp will be what here? Nc. Okay, and after that, what is there? They are asking the charge on each capacitor. That already we have calculated, na? That already calculated, na? This Q1, Q2, Q3, na? That already, previous slide already we have calculated, na? Calculated here. Okay, great, see, very well. Q1, Q2, Q3 already we have calculated. But you know what is there? Which kind of capacitors are there? N capacitors are there, okay? So we have calculated this one here, no? Just let me change here. See, we have calculated for which one? Non-identical, but here it is given here the normally. So what will happen that here, see, you know, na? C1 by C1 plus C2 plus C3, so see here. If in case 3 is there, so see, C plus C plus C into Q, what will come here? It will become here Q by 3. Getting? Correct? Correct? Huh? Correct only. Similarly, Q2 how much? Q by 3. Q3 how much? Q by 3. Is it? So if I write for the n plates, which plates is, students? For n plates, what this will become here? On each of them, charge will become here Q by n. What will become charge on each of them, students? It will become here Q by n. Okay, this is we have written for the three capacitors, but this is for which one? N capacitors. Okay, great. Now students, now we are going to see somewhat mixed combination. No? Series and parallel we have understood. Now let's see mixed combination. Okay, so see, so very easy. Let's take what is the other students. See, if in case it is given like this. Now first we'll do like this here. See, it is given like this, mixed combination. Now let's take here A and here B. Okay, let's take here C1, C2, C3. Now let's take like this given here. So what will happen that here, what we can tell, C1, C2 is connected in series. Okay, so if you are draw here the equivalent here, equivalent. So this C1, C2, now this C1, C2. This C1, C2, they are in a series. That means what will become here? See, this will become here, students. See, this will become C1, C2 by C1 plus C2. Okay, and after that here, what is there here? C3, is it? And here terminal A, here terminal B. So can you tell me very well what equivalent will become here? CAB. Now this and this in parallel. So we can write here C1, C2 by C1 plus C2 plus C3. Is it? This one we have done here. Similarly, let's take here, if I take like this, for example, see this one, and after that let's take here this and this, for example. Okay, and now let's take what is given here. They all of them are identical here. C, 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 C. Can you tell very well what is the equivalent here? C, C, A, B. Now see, directly I can write here, C and C in series, C by 2. C and C in series, C by 2. Then this C by 2, this C by 2 in a parallel. Okay, so what will become here? C by 2 plus C by 2. It will become what? Again C. Okay, so if you see here, even I can draw here the equivalent diagram also. See here, this is C by 2, this is also C by 2, is it? And these are the points are there, A and B. Okay, so if in case mixed combinations are there, you have to identify where are the series, where are the parallel, and then you can do here. Now and see here, these are the, I have taken the equivalent here. Now this one here, is it? Like this here. Okay, great. Now students, let's see the next one. If I talk about here, let's take, now I'm going to talk about here the dielectric. Okay, and let's take, now I have taken the plates like this. Now this plate I have taken here, M, N. Okay, and now how I'm going to fill the dielectric? Let's take first dielectric I have filled like this here. Now this dielectric I have filled here. Let's take here K1. Okay, and this dielectric here we have divided like this here. Now let's take here, this is what? K2, and students, let's take here, this is. Now mixed combination we are seeing. This is what? K3. Okay, and now let me write here the distances. Let's see. This distance is D. This distance how much here? D. Okay, and now students, let's say here, this one how much here? D1. This one how much here? D2. Okay, and area also we have to see. Let's take this area is A1. Okay, and this area is how much? A2. Okay, so how many capacitors are there, students? 3 capacitors are there. Now, if I draw here the equivalent diagram, okay, so you know what will happen that here, like this it will happen. This and this in series, okay, and this one will come in a parallel here, like this. Okay, like this we'll get here, and we'll write here this is M and this is N. Let me give the names here. So see here, please, this is C1, is it? This is C2 and this is C3. Now from the mixed combination we have to take. Okay, so if I write here the one by one, C1 will come what here? C1, see here, K1 epsilon naught, and see here please, actually little bit problem happened. What problem happened now? Because see here K1. So okay, here I will take here A1 now, and here I will take here A2. Okay, now okay. So what we can write here? K1 epsilon naught A1 by D. This one. Okay, similarly C2 how much? See here, this one I have taken C2. So what will become here? See, K2 epsilon naught A2 by how much this distance is there. Okay, so students here please see, this is D1, this I will take D2. D1 no? This is D1, this I have taken D2, and this I have taken D3. Now okay, it should be somewhat similarity should be there, no? Then only we can enjoy. So K2 epsilon naught A2 by D2. Similarly C3 how much? This one here you can write here, see, K3 epsilon naught, that area we can't do anything, so A2 by how much? D3. Okay, so students, before also I have told you in this situation what is the equivalent here. So if I write here the equivalent, CMN will come here. See, this C2 C3 now series, so we can write here, see, C2 C3 by C2 plus C3 plus C1. Okay, so in this formula you have to just put all this here and you can get here the equivalent between them. Okay, great. Now students, see this one. This one is somewhat interesting, see, because before that I have told about the series and parallel, but here what will happen? Mixed combination will happen. Okay, so see here what is here, see, I have taken here this is A, and this one I have taken here B. Now, and see, let me give here this plates. So see, 1, 2, 2, 3, 3, and here how much? 4. Okay, so can you tell me here how many capacitors will form? See, C12, this is C23, this is how much? C34, is it? But how to draw now? Is it? We are going to draw. Start with one terminal A. No, start with the one terminal A and see. From A, how many plates are connected? 1 and 4. Okay, so like this, connect here the plates here. See here, 1, 4, we have connected. After that, students, see here, this 1 and 4, this one is making C12, this is making how much? C34. So students here, see, this we are going to make one capacitor, 2. Now this 1, 2, this one here, is it? So what is the name here? This is the C12, is it? And here also again what is there? 3, 4. So see here, this one we have made here what? 3. What is this capacitor? C34. Okay. Now what will happen at here, students? See, we have make this capacitor we have made it. Now this capacitor is there between which and which? 2 and 3. So see, from 2 1 plates will come 2, and from here also 1 plate will come 3, is it? And this 2 3 is connected to what? This 2 3 is connected to the terminal like this here. Okay, so see, this kind of situation is there. Here you know what will happen, students. See, you can see here this one and this terminal is having the same potential. That means, for example, if here potential is VB, here potential is VB, potential difference how much? 0. And you know Q equal to C into delta V in a very standard form. That means this capacitor will not store any charge, any energy. That means this capacitor can be removed, is it? So students, when you will remove this capacitor, what will come here? Then we'll be left with the only 2 capacitors. Now like this here, we'll be left with the only 2 capacitors. What is the name of the capacitors? This one is C12 and this is the C34. Both of them connected in a, see here, parallel, and they are identical also. So C plus C, 2C. Okay, and we can write here 2 epsilon naught A by D, is it? So here you can see very well how we have got here this thing, is it? Now we'll come to this one here. Okay, see, this is A, this is B. Okay, and what is there? Some plates are shorted also, but let me first write the numbers. See, 1 2 2 3 3 and 4. 4 plates. How many capacitors? See, and tell how many capacitors? See here please, C12 here, C23 here, how much? C34. Okay, and now we are going to see this side. Okay, so first what we are going to do, we are going to draw here the equivalent diagram is there now. So what we can do here, please, I have started with the A. Okay. Now you have to decide from A, how many capacitors are connected. See, from A, this 2-1 is there and 2-3 is there. Okay, so see here I have taken here the 2 and here also I have taken here the 2. Okay, so from A I have take 2. Now we have to draw one more plate. What is this? 1. Now this capacitor, for this capacitor. Then after that, what I have to draw here, see 2, 3. 2, 3. Okay, you can see very well. C21 and this one here. C21 no, or C12. This C12 and what is this here? We can write as C23. Okay, so these two capacitors we have completed. Now after that, what is there, students, here? Say from B. From B, how many capacitors are there? 3 and 3. See here, this B, what is there? 3 and 3. Okay, so see now. Now students, here you can see very well. This A we have made it now. So see, this 3 is there now. So from 3, what is there? We have to take here this 3. Now, so see here we can take here the one more 3 here. This 3, is it? This 3 and 4. But you can see very well, this 4 and 1 is what, students? This 4 and 1 is the shorted. You can see very well, this 4 and this 1. Now this 4 and 1 is shorted. You can see very well, this 4 and 1 is shorted. Okay, great. Now students, after that, now point B is connected to where? 3. Point B is connected to where? See here. You can see here. Point B is connected. You can see very well. Is it? This is the equivalent here. I hope so. We are doing very well. Is it? So students, we'll just draw here one more time here. See A. Then it will be very easier. See. Here we can draw here. See. This is the 2, 1. Now we can draw somewhat more better here. See. 1 and 4 shorted. Then we can draw here the 3. Is it? And here what is there? 2, 3. Is it? See now 2, 3. Now the diagram will look somewhat better. See here, please. Now you can see both are same diagram only. Okay. So now students, you can see very well, as the capacitors are identical, we know very well. C12, this is C34, this is C23. But you know very well, students, see, identical only. So see, this C and this C in a series C by 2. This C by 2 and this C in a parallel. So C by 2 plus C, how much? 3C by 2. Is it? So if I write here, this equivalent between A and B will come what here? Again, I'm telling 3C by 2. Okay, so 3 by 2 epsilon naught A by D. Is it? So students, you can see very well how we have done. When you will see the video again one more time, you can understand it very well. So students, keep studying, keep growing.